Welcome back to The Explainer. Today, we're standing right at the edge of what I'd call the next massive leap in our digital evolution. We're exploring the digital frontier of autonomous connection. Look, if you think our world is hyper-connected right now, well, buckle up. Imagine, just for a second, that every time you wanted to call a friend, you actually had to physically walk down the street and plug a wire into a giant switchboard. Sounds crazy, right? But honestly, that is essentially what our network servers have been doing for decades. But right now, the way our technology communicates is fundamentally transforming behind the scenes, and it's going to change absolutely everything about how our digital infrastructure operates.
Okay, let's dive into this. The core idea here is that we are moving from a world where we connect machines to a world where machines connect themselves. Think about it. For decades, we human beings have been the ultimate matchmakers for our tech. We plugged in the cables, we typed in the passwords, we manually configured the servers just to make sure data could flow from point A to B. But you know, that era, it's ending. The machines are literally taking the wheel now.
So here's our roadmap for today's Explainer. First, we'll be defining autonomous connection. Then we'll look at the evolution of connectivity, followed by real-world applications today. After that, navigating the digital frontier, the challenges and implications, and finally, the future of connection. Let's get to it.
Section 1. Defining autonomous connection, or the what. So what exactly is an autonomous connection anyway? Well, simply put, these are digital systems that independently establish, manage, and optimize data routing and network handshakes completely without human intervention. The best way to think about this, it's kind of like a self-driving car, but specifically for data. Just like an autonomous vehicle senses a traffic jam, adjusts its speed, and reroutes around an accident without you ever touching the steering wheel, these networks do the exact same thing. They sense data congestion, they negotiate security protocols, and they instantly find the most efficient pathways totally on their own. You just get to sit back, relax, and let the system optimize itself.
And this brilliantly illustrates the stark contrast between our past and our future. Traditional networks require manual setup. They rely on these rigid, immovable pathways, kind of like laying down heavy steel train tracks. If a server goes down, a human literally has to diagnose the issue and physically fix the route, while the whole train system just grinds to a halt. Autonomous networks, on the other hand, are more like flying a helicopter. They're entirely self-configuring. They use AI-negotiated handshakes to securely connect in mere milliseconds, making them infinitely adaptable. The freedom and efficiency we're talking about here are absolutely unparalleled.
Moving on to Section 2, the evolution of connectivity and how exactly we got here.
Let's rewind a bit. Back in the 1990s, we had our static origins. This was the era of manual hardware links. If you wanted computers to talk, you were physically tripping over miles of tangled cables to connect them. And a severed wire, that meant a total blackout. Fast forward to the 2010s, and we entered the era of automated processes with software-defined networking. Humans still wrote the rules, sure, but software actually executed them, which removed a major layer of friction. And that brings us to the 2020s and beyond, autonomous systems. Here, AI-driven connectivity doesn't just follow our rules, it writes its own rules based on real-time conditions. With every single step forward, we've basically systematically removed the human bottleneck from our networks.
Section 3. Real-world applications today, or the how.
Okay, so here is exactly how these autonomous connections form seamlessly in the background of our digital lives. Step 1 is device detection. Two devices or nodes recognize each other's presence on a network pretty much instantly. Step 2 is really where the magic happens, the AI handshake negotiation. Instead of waiting for a pre-programmed prompt, AI algorithms instantly verify security credentials, they assess bandwidth capabilities, and they agree on the absolute perfect transmission protocol. Finally, Step 3. Optimal data routing setup. The system builds the pathway and just begins transmitting. And the crazy part? All of this happens in a fraction of a second. No loading bars, no putting in IT support tickets, just instant, intelligent connection.
So, what's the result of that lightning-fast three-step process? A staggering 99% reduction in network latency and downtime. 99%. By using these AI-negotiated handshakes, the honestly, agonizingly slow human reaction time is completely bypassed. I mean, an algorithm can reroute massive flows of data traffic around a failing server in microseconds. That near-total reduction represents immense cost savings for companies, totally unmatched reliability for users like us, and a fundamental structural upgrade to our global digital infrastructure. It's a real game-changer.
Let's move to Section 4 and see how this builds out. Navigating the digital frontier and why it matters to you.
Now, when we hear the word connectivity, we usually think of the smart devices sitting in our pockets or our living rooms, right?
But consumer devices actually only make up 15% of this expanding frontier. The vast majority of this revolution is happening on a much, much grander scale.
35% is the industrial Internet of Things.
Picture these massive automotive manufacturing plants where autonomous machines are actively communicating to optimize supply chain flows or even catch assembly line defects on the fly. And then, a whopping 50% is smart infrastructure. We're talking about national power grids perfectly balancing energy loads, smart traffic systems optimizing city transit routes in real time, and entire cities autonomously talking to themselves just to keep critical operations running flawlessly.
Now, what's really interesting about this is when you compare these models side by side, it becomes incredibly clear why industries are rapidly abandoning traditional routing. The setup time? It plummets from days down to mere milliseconds. The error rates plummet as well when you take manual human input out of the equation, because let's face it, we make typos, right? And when it comes to adaptability, traditional networks are largely static and, well, brittle. Meanwhile, AI-driven networks are relentlessly dynamic. They literally heal themselves when pathways break. The hard data paints a really clear, objective picture of why this transition is simply inevitable for modern industries.
Which brings us to Section 5, Challenges and Implications, and the Hurdles Ahead.
Of course, any shift of this magnitude introduces some really significant complexities. First up, there are data privacy and consent risks. When systems connect and share data autonomously, how exactly is personal data safeguarded when human oversight is completely removed from the loop? Second, there's a big ongoing debate regarding AI ethics in network decision-making. For example, if a city's network gets overloaded during a crisis, how does the AI decide whose data gets prioritized, and who even decides those ethical weightings? Finally, we have to look at job automation impacts in the IT sector. As networks become fully self-configuring and self-healing, what exactly is the future role of traditional network engineers? These are complex, really multifaceted questions that the industry is actively analyzing and trying to navigate as we speak.
And that leads us into Section 6, the future of connection, the why.
So, the crucial point here is that over the next 5 years, the growth of autonomous network nodes isn't just going to be a linear progression. We're talking about a steep, exponential explosion. We are actively witnessing the unstoppable, compounding scaling of autonomous systems across global infrastructure. The combined benefits of speed, reliability, and sheer scale are simply way too great for industries to ignore. This isn't just some flashy new tool. It's the new bedrock upon which the entire future of digital communication is going to be built. So I'll leave you with this. As machines seamlessly connect themselves, and as these massive global networks become entirely self-sufficient, how will our human role evolve in this expanding digital frontier? If we're no longer the matchmakers for our technology, what exactly will our new purpose be? It's a lot to think about. Thank you so much for joining me for this explainer. Keep asking questions, keep exploring the data, and I'll see you next time.